So, let us take now an example on Gauss-Seidel method, right. So, we will take look it as far as classroom exercise is concerned. We cannot consider large size of problem, for that you need a computer, right. So, we have taken a 3 bus power system. Bus 1 is a slack bus, and bus 2 and 3 it considered as a PQ bus, right. And this thing solution, for exact solution it will take more number of iterations, but what we will do, we will perform only 2 iterations, such that things will be clear. This is when both the buses are of PQ type, and another example we will take on Gauss-Seidel for PV bus, right. So, you have to use the first one is using the Gauss-Seidel method, determine the your values of the voltage at buses 2 and 3, right. And second one is that find the slack bus real and reactive power after second iteration only, right. Data will be given, right. And your part C will be your determine the line flows and line losses after second iteration, right. And neglect line charging admittance. So, line charging admittance is not considered, and data are given like this. Base MVA is 100, right. So, in this case 3 buses, bus 1 is a slack bus, and slack bus voltage has been considered as 1.05 plus J0, this is fixed, and starting values for bus 2 and this is assumed bus voltage, bus 2 and bus 3 you take 1 plus J0, 1 plus J0, although at the time of developing the theory we have said that flat voltage start is better. That means, if it is 1.05, other two also initial values should have been 1.05 plus J0, right. But here we have taken that initial values 1 plus J0 and 1 plus J0, and bus 1 is slack bus. So, no parameter, no generation, no load should be there. By chance at slack bus if some load is there, so that is actually dummy load, and you do not need anything during iterative process. But if load is there at the slack bus, right, then what you can do, you do not consider, it will never come in your iterative process, but when you get the slack bus power, right, that is PG1 and QG1 real and reactive power, whatever you get, and if any load is there at the slack bus, so that with that PG1 whatever you got, that load also you have to get it. Later I will tell you this thing, right. And otherwise if anything is given also, this will be act as your dummy parameters for your iterative process, right. And load at bus 2 is given 50 megawatt, 30 megawatt, base MVA is 100, and load is also given 305.6 megawatt, 140.2 megawatt, right. And bus 3 there it is not, it is a load, but there is no generation there, no generator connected. So, 0, but load is 138.6 and megawatt and 45.2 megawatt, right. And line impedances are also given, it is 1 to 2, 1 3 and 2 3, all are given, these are in per unit value. So, the impedance is a per unit value, these voltages are also in per unit values, but these are given in real unit, megawatt and megawatt. So, you have to divide all this thing by 100, because base is 100, such that they can be transformed into per unit, right. So, next is that how we will go for step by step calculation. So, in that case, that your step 1, that initial your computation, first is you have to convert all the loads in per unit values. So, at bus 2 load is PL2, so 305.6 by 100, so 3.056 per unit. Similarly, QL2 also 140.2 by 100, 1.402 per unit. Similarly, PL3 138.6 by 100, so 1.386 by 6 per unit, and QL3 45.2 by 100, 0.452 per unit, right. Now, all the convert all the generation in per unit values. There at bus 2 it is given PG2 50 megawatt, so 50 by 100, 0.5 per unit, and QG2 is 30 by 100, so 0.3 per unit, right. So, all these things given. Now, compute net injected power at bus 2 and 3, right. So, net injected power means this one. Suppose you have a generation, in general I am talking, say this is bus I, and you have the load, right. Say you have PLI plus JQLI for bus I, right, and here also say PGI plus JQGI, right. So, in this case that net injected power will be, right. So, make it like this, that Pi and Qi will be the net injected power, right. So, Pi will be actually PGI minus PLI and Qi will be QGI minus QLI. This is the net injected power at this bus, right. You take the injection one, because this is power being injected and load is going out. So, net injected will be PGI minus PLI, right. Therefore, your P2, that is at bus 2, it will be Pg2 minus PL2. I told you that Pi is equal to PGI minus PLI. So, it is P2 is equal to Pg2 minus PL2. So, 0.5 minus 3.056. So, it is minus 2.556 per unit. Similarly, Q2 is equal to Qg2 minus QL2. So, 0.3 minus 1.402. So, it is minus 1.102 per unit, right. And P3 is equal to Pg3 minus PL3, but at bus 3 there is no generation, at bus 3 there is no generation, that means 0, Pg3 and Qg3 0, right. Therefore, it is 0 minus 1.386, so minus 1.386 per unit, and Q3 is equal to Qg3 minus QL3, so 0 minus 0.452, that is minus 0.452 unit, right. This way you convert. This is the first step. First step is these are all initial computation, right. Now, second step is that your formation of your Y bus matrix, right. So, all Z I value, ik values are given. So, first you find out small y12 is equal to small y21 1 upon z12. So, this value is given 0.02 plus j 0.04. So, that is 10 minus j20, right. Similarly, y13 equal to y31 is equal to 1 upon z13 is equal to 1 upon 0.01 plus j 0.03, that is 10 minus j30. Similarly, y23 equal to y32, all small y, right, small y. Do not confuse between capital letter and small letter. When it is capital letter, that I showed you that your Y matrix, right, and this is only for the line admittance, right, different line admittance, that is 1 upon z23, that is 1 upon 0.0125 plus j 0.025. So, 16 minus your j32, right. Now, charging admittance is neglected. So, y11 is equal to y12 plus y13 plus y10. I mean charging admittance, I mean if you find out y11, so it will be y12, y13 plus y10, but charging admittance is neglected. So, y10 is 0, right, here it is 0. Therefore, y11 is equal to small y12 plus small y13. So, 10 minus j20 plus 10 minus j30 is equal to 20 minus j50. Similarly, y22 will be y2 small y21 plus small y23, no charging admittance because we have not considered that. So, y12 is equal to y21 is equal to y12. So, y12 plus y23. So, if you sum it up, it will be 26 minus j52, right. Next is your this thing y33, capital Y33, small y13 plus y23. If you sum it up, it will be 26 minus j62. Now, this capital Y11 from here it is coming, right, capital Y11 its magnitude will be 53.85 and angle minus 68.2 degree. Similarly, capital Y22 will be 58.13 angle minus 63.4 degree, and similarly capital Y33, right, this one will become 67.23 minus angle 67.2 degree, right. So, this all diagonals diagonal elements of the Y matrix made it, right, y11, y22, y33. Next, the off diagonal elements. Off diagonal elements, capital Y12 is equal to minus your small y12, right. So, minus 10 minus j20. So, this will be 22.36 angle 116.6 degree, right. So, that we are capital Y12 is equal to capital Y21, right. It is matrix is symmetric. So, capital Y13 is equal to capital Y31 is equal to minus Y13 is equal to minus 10 minus J30, it will be 31.62 angle 108.4 degree, right, and Y2 capital Y23 is equal to capital Y3 or 32 is equal to minus small y23, it will be minus 16 minus J32. So, this will become 35.77 angle 116.6 degree, right. So, with that you form the Y bus matrix Y11, Y12, Y13. So, Y bus matrix is formed, right. So, after this step 3 iterative computation, right. So, in that case you have to write down first all the 3 equations for the Gauss-Seidel method. We have seen that the equations for the Gauss-Seidel method. So, all these things are given in general, right. So, for the bus 2 we are writing V2 P plus 1, right. This you are already we have just hold on, already we have discussed this, right. Let me find out, right, here already we have discussed all these things, right. For example, for a 4 bus system already we have discussed all these things for a 4 bus system, but in this case we are considering only your what you call, there is a 3 bus problem. So, you have only 2 equations because bus 1 is a slack bus. So, V2 P plus 1, right, P is the iteration count is equal to 1 upon capital Y22 and in bracket P2 minus JQ2 upon V2 P then conjugate minus Y21 V1 minus Y23 V3 P. This is equation 1, and as V1 is a slack bus. So, please do not put here any iteration count because throughout this thing V1 is a slack bus and its voltage is taken 1.05 plus J0. So, that will remain constant, right, and all buses are PQ buses, that is Y21 anyway this is admittance matrix element. So, this will remain constant and P2 and Q2 also will remain constant throughout the iterative process, right. So, only variable here is that is your V2, that means magnitude angle both these 2 things, right, because this is a complex one, this is a complex voltage, right. So, this is in general we write 1 upon Y22, then this is the for V2, right. Similarly, for bus 3 same way you can write for bus 3 that V3 P plus 1 Y33 P3 minus JQ3 upon V3 P conjugate, P is the iteration count anyway, minus Y3 V1 Y31 V1 minus Y32 V2 P plus 1. So, instead of P you write that immediate values whatever you have obtained. So, V2 this one will be computed first V2 P plus 1. So, instead of taking V2 P you take V2 P plus 1 such that your convergence will be faster, that is the number of iteration will be less, right. So, these 2 equations you have got, right. Now, slack bus voltage V1 is given 1.05 plus J0, this is given. Now, starting values, it is all data it has given starting values 1 plus J0. So, V2 0 is equal to 1 plus J0, that is the initial values, and V3 0 superscript we have taken in bracket 0, right. So, 1 plus J0, these are the initial values. Now, what we will do that except your what you call except V3 and V2 both the equations here are here, V3 and V2 all are constant throughout the iterative process. So, for example, that how we will compute, for example, this equation look I am writing here this equation that you can write V2 P plus 1 equal to, right, you can write P2 minus JQ2 multiply this Y1 Y22 right into 1 upon V2P conjugate, right, then minus Y21 upon Y22 all are capital into V1, then minus Y23 upon Y22 V3P, right, because this term actually constant throughout the iterative process, this one also constant throughout the iterative process, and this term also constant throughout the iterative process, right. That means, if you compute this term and put it in that equation, then no need to compute these terms again and again, right. So, that is why in your computation that first you compute this term P 2 minus J Q 2 upon Y 2 2 and Y 2 1 upon Y 2 2 and Y 2 3 upon Y 2 2, all capital, right. First you compute. Therefore, your this thing your P 2 minus J Q 2 upon Y 2 2, P 2 and Q 2 already we have got that per unit values before all I have shown. So, this is minus 2.556 plus J 1.102 and Y 2 2 also we have got 58.13 angle minus 63.4. So, this will come actually 0.078 angle 220.1 degree, right. Similarly, next is I told you that Y 2 1 upon Y 2 2, I mean all these things you have to compute, Y 2 1 upon Y 2 2, Y 2 3 upon your Y 2 2, all you have to compute. So, then Y 2 1 upon Y 2 2 will be, you substitute these two values, right, 22.36 angle 116.6 degree and this is 58.13 angle minus 63.4 degree. So, that will become 0.3846 angle 180 degree is equal to minus 0.3846, right, it will come like this. Similarly, capital Y 2 3 by capital Y 2 2, that is 35.77 angle 116.6 degree and this is 58.13 angle minus 63.4 degree, that is 0.6153 and again angle is 180 degree. So, minus 0.6153, right. So, these are the parameters for this equation 2, so equation V 2, right. This will not change throughout the iterative process and they will remain constant, right. Similarly, for this equation also you have to compute P 3 minus J Q 3 divided by Y 3 3, this you compute, then Y 3 1 upon Y 3 3 you compute because you multiply this one by 1 upon Y 3 3 and similarly minus Y 3 2 by Y 3 3 when you multiply this you compute because these are the term, it will remain constant, right. So, that means your if you do so, then your what you call the first you write, then your equation 1 V 2 P plus 1 first you write, all this we have computed that P 2 minus J Q 2 upon your Y 2 2. So, this is 0.0478 angle to 220.1 degree divided by V 2 P conjugate plus, because it was minus 0.3846. So, it is plus 0.3846 V 1 and here also it was minus 0.6153. So, it is plus 0.6153 V 3 P because, right. So, this is the equation 3 set, this is for V 2 equation. Similarly, for V 3 you again compute P 3 minus J Q 3 upon capital Y 3 3. So, P 3 Q 3 all you have computed, Y 3 3 capital Y 3 3 can substitute here, you will get 0.0217 angle 229.2 degree. Now, the ratio you have to compute capital Y 3 1 by capital Y 3 3. So, Y 3 1 known to you, Y 3 3 known to you. So, that is actually coming 0.47 angle 175.6 degree, right. Similarly, another one that Y 3 2 upon Y 3 3 the capital one, capital Y 30, this put this value 35.77 angle 116.6 degree and 67.23 angle minus 67.2 degree, you will get 0.528 angle 183.8 degree, right. Therefore, that equation 3, right, that means that this equation, that means this equation, right, it can be written as V 3 P 1 is equal to 0.0217 angle 229.2 degree by V 3 P conjugate minus 0.471 angle 175.6 degree into V 1, then minus 0.532 angle 183.8 degree into V 2 P plus 1, right, where we are putting V 2. This is equation 4. Now, this equation, this equation we put it at equation 3 and this one we made it at equation 4. This you have to solve iteratively, right. So, all the constant parameters first you compute because those parameters will not change throughout your iterative process, right. Then you solve equation 3 and 4 iteratively. First iteration you put P is equal to 0, right. Therefore, when you put P is equal to 0, it will be V 2 1 and this will be 0.0478 angle 220.1 degree V 2 zeros conjugate plus 0.3846 V 1 plus 0.6153 V 3 0, right. So, V 1 1.05 we know that 1.05 plus J 0.0 we know that, V 3 0 also 1 plus J 0 we know that, right. and your this thing your V2 initial value is also 1 plus J 0. So, here also it will be 1 plus J 0 conjugate means it is 1, right. So, substitute these values V2 1 is equal to this one divided by 1 plus J 0 conjugate, I mean it is 1 actually, 1 minus J 0 means 1 only, then 0.3846, V 1 is 1.05 plus J 0 and your other term 0.6153, initial value of V 3 0 1 plus J 0, then you compute all this, right. If you do so, if V 2 1 will come for first iteration 0.98305 angle minus 1.8 degree, right. Similarly, for V 3 also you put again that P is equal to 0. So, V 3 1 will be this one, already you have got it, divided by V 3 0 conjugate, right, minus 0.47 angle 175.6 degree V 1, right, then minus 0.532 angle 183.8 degree, that is your V 2, that is 1 in first iteration. That means, this value do not put here V 2 0, right, immediate value should come in the next equations, right. So, here V 2 1 is this one. So, we make V 2 1, right, and all then you substitute all V 3 is 1 plus J 0 conjugate and minus 0.47 angle 175.6 degree 1.0 into 1.05 plus J 0, right, and this is minus 0.538 angle 183.8 degree into 0.98305 angle minus 1.8 degree. So, V 3 1 will come is after calculating all, you will get 1.0011 angle minus 2.06 degree, right. That means that after first iteration this is the result, V 2 1 is equal to this much and V 3 1 is equal to this much, right. Now, second iteration, when you will go for second iteration, these values remain constant, all constant parameters are computed before. So, V 2 second iteration V 2 2, right, when P is equal to 1, it will become 0.478 angle 220.1, that is fixed, divided by that first iteration value whatever you have got for V 2, that is 0.98305 angle minus 1.8 degree. So, 0.98305 angle minus 1.8 degree conjugate, right, plus 0.3846 into 1.05 plus your J 0.0. This term actually remain constant because V 1 is also constant, right, because it is a slack bus. This term also will not change, plus 0.6153 into 1.011 angle, that your this minus 2.06 degree, this value we got for V 3 1. So, if you make it, so V 2 2 in the second iteration 0.98265 angle minus 3.048 your degree, right. Similarly, V 3 2 also you calculate, here also say this term we have got earlier and this is 1.0011 we got in first iteration. So, angle minus 2.06 degree conjugate, right, conjugate, it is conjugate, minus 0.471 angle 175.6 degree into 1.05 J 0. This term actually remain constant because V 1 also not change, a slack bus voltage, right. Then minus 0.532 angle 183.8 degree into that this V 2 2 voltage you have got it here 0.98265 angle minus 3.048 degree. This value directly you substitute here, right, that one you do it. So, if you do so, so you have put it there. So, if you do so, V 3 2 will come 1.00099 angle minus 2.6 degree. So, this is up to this is only 2 iterations. We are not sure that whether solution has converged or not, right. So, if you do by your calculator another 2-3 iterations, then you may be knowing, right. So, this is the steps to show you that how one can compute using Gauss-Seidel method, right, how one can solve the problem, right. So, only 2 iterations have been made, right. So, that is sufficient to understand this, right. So, next is that after second iteration your this is your what you call this is your V 2 0.98265 angle minus 3.048 degree and V 3 2 1.999 angle minus 2.68 degree, right. So, this is your V 2 V 3. After second iteration only you have been asked to compute the slack bus power. So, after second iteration slack bus power from equation 41, right, that means this is equation 41, right. We have when we are explaining all the algorithm for the Gauss-Seidel method in step 4 computation of slack bus power. So, when I for slack bus power we have taken I equal to 1. So, P1 is equal to k is equal to 1 to n, then V1 Vk y capital Y 1 k all are magnitude, right, cosine theta 1 k minus delta 1 plus delta k for 2, this is for P1. Similarly, for Q1 this expression, right. So, after second iteration you and your n is equal to, for our case n is equal to 3, because we are considering your 3 bus problem. Therefore, equation 41 for P1 can be written as k is equal to 1 to 3 V1 Vk capital Y 1 k all are magnitude, then cosine theta 1 k minus delta 1 plus delta k, right. So, when you will do such computation you have to have lot of patience, right, otherwise there is every possibility to write this equation, there is a term you can miss, there is this possibility. Second possibility is that calculation error, that calculator error, right. That means, you will, if you try to compute very fast, then you have to be very careful that you are calculating correctly, otherwise there is a possibility of a mistake, right. So, if you expand this, it will become magnitude V1 square, then magnitude Y11 capital Y11, then cos theta 11 plus magnitude V1 magnitude V2 magnitude capital Y12 cosine theta 12 minus delta y plus delta 1 plus delta 2, right, plus magnitude V1 V3 magnitude Y13 cosine theta 13 minus delta 1 plus delta 3. Now, after second iteration you have got this voltage after second iteration, right, and all the angles are known, theta 11 that is that angle of capital Y 11, that angles are known, right, angle of capital Y12 Y13 all are known, right. So, and then the delta 1 is your what we call delta 1 is 0 because slack bus voltage 1 plus 0.05 plus your J0. So, delta 1 is 0 and delta 2 after second iteration is minus 3.048 degree and delta 3 after second iteration minus 2.68 degree, right. So, here you have to substitute all this data. So, in this case magnitude V1 is 1.05 and delta 1 is 0, that is slack bus angle, right. Then magnitude V2 is this much, we have computed after second iteration, just now I showed delta 2 is minus 3.048 degree. Magnitude V3 1.0099 and this delta 3 is minus 2.68 degree. Now, capital Y11 53.85 and its angle was minus 68.2 degree, all we have computed, right. And capital Y12 is 22.36 and theta 12 is 116.56 degree, all computed. Capital Y13 is equal to 31.62 and theta 13 is 188.4 degree. So, with this you substitute all these things for P1, right, this P1, right. So, if you do so, then you will get P1 is equal to 3.84 per unit megawatt, base MV is 100, if you multiply it is 384 megawatt, right. Similarly, for equation 42, again in step 4 of that algorithm, right, that means this equation, again this equation you put n is equal to 3 for this bus and find out what is the your reactive power of the slack bus Q1, right. So, in this case we are putting from equation 42, that means this equation, this is your equation 42, this is equation 42, right. Therefore, Q1 is equal to minus k sigma k is equal to 1 to 3 magnitude V1 magnitude Vk magnitude Y1k sine theta 1k minus delta 1 plus delta, expand this, right, you expand this and when you expand this it will be like this, right, it will be like this and then you substitute all the parameters whatever we have given here, you have whatever we have given here, all the parameters here, all the parameters here, right. So, you substitute and upon substitution you compute, it is becoming 1.9786 per unit, right. We call sometimes we call per unit megawatt, right, because it is actually per unit megavar not megawatt, this is Q, right, that is multiplied by 100. Some it is per unit is sufficient, we per unit megavar we want to mean that it is real unit is megawatt, that is why we call per unit megawatt, right, but otherwise you just put per unit, no problem, right. So, it is equal to 1.9786 into 100, so 197.86 megavar, this is after second iteration, right. Now, again from equation 34, that whatever your what we call that loss formula, sorry not loss formula, that your line power flows formula, right, line power flows formula, that PIK expression you have got in equation 34, same expression we are you are writing here, just put I is equal to 1, k is equal to 2. So, this is your line flows formula, right. Just put I is equal to 1, k is equal to 2 and put all the parameters, right, and put all the parameters. So, in this case when you put all the data, you will get P12 is equal to 1.8189 per unit megawatt we call. So, that is 181.89 megawatt, multiply this per unit value by 100. Similarly, when your I is equal to 1, k is equal to 3. So, P13 easily you can get it. I mean, in this expression, that equation 34, you can find out I is equal to 1, then k is equal to 2, I is equal to 1, k is equal to 3, I is equal to 2, k is equal to 3, P23, right, all you will get it. So, similarly, P13 also this is the thing, and then you will get upon substitution of all the data, put all the data here, you will get P13 is equal to 2.0 per unit megawatt, that is 200 megawatt multiplied by 100. Similarly, P23 also when your I is equal to 2 and k is equal to 3. So, this is the expression, right, put it, you will get it. P23 is equal to minus 49.03 megawatt. The minus sign indicates actually power is flowing from 3 to 2 actually, as 2 to 3 is showing minus 49.03 means power actually flowing from 3 to 2, right. So, thank you, I can be back.